Hi everyone, my name is Bhartich and in this video we will be discussing another theorem regarding to convergent sequences. In our previous video we have discussed two theorems that where every convergent sequence is bounded and the converse of it which was not true. In this particular video we will be discussing theorem that says a sequence cannot converge to more than one limit. To prove this theorem, we will use the method of contradiction where we will be taking a convergent sequence and we will be considering that it has two limit points. We will be proceeding through the assumption that we have taken, and at the end we will be seeing that with the assumption that we have taken, there arises some contradiction. So let us consider a sequence Sn such that it converges to two real number, that is L and L dash. Now as I've already said you that you can choose epsilon any number. So here to prove this whole theorem, I'm considering epsilon to be equal to as 1 by 3 mod of L minus L dash, and definitely this is going to be greater than 0 as we have already taken that S1 converges to the point L and L dash. So according to the definition, what we can write that there exists for the first, if it converges to L, if Sn converges to L when n tends to infinity, it means that there exists a positive integer m1 such that mod of Sn minus L is less than epsilon for all n greater or equal to m1. Now, similarly for the case 2, if Sn converges to L dash when n tends to infinity, again we have a positive integer m2 such that Sn minus L dash is less than epsilon for all n greater or equal to m2. Now from equation 1 and 2, this is my equation 1 and this is my equation 2. From 1 and 2, for n greater or equal to maximum of m1 comma m2. Now do not confuse. Suppose why we have written this, that suppose m1 value is 7 and here m2 value is 9. Whatever the maximum of 7 and 9 will be there, this relation will always hold. That's why we have written, if we combine equation 1 and 2 for n greater or equal to maximum of m1 and m2, still we will be finding there exists a positive integer m such that the relation will be true. Now let us we are finding for, so this result we are finding for n greater or equal to whatever the maximum of m1 and m2 will be there, we consider that to be m. Now for that what we can do is that let's calculate the value of L minus, let's make some possible arrangement. L minus Sn plus Sn minus L1. We will use the triangle inequality, and in the previous video only I have explained you how the triangle inequality works, and here what we can do is that this value is always going to be lesser or equal to the individual this and this sum modulus. So modulus of L minus Sn plus modulus of Sn minus L dash. Now look what this value is going to be thus what we can write down is that this whole mod of L minus L dash is going to be lesser or equal to this whole value here. But what we know, L minus Sn is epsilon. Let's put down the value of epsilon, and Sn minus L dash, which is this one, is also an epsilon. So epsilon. Now this whole value is going to be lesser or equal to 2 epsilon. But recall what the value of epsilon that we have considered. The value of epsilon that we chose was, epsilon was taken as 1 by 3 modulus of L minus L dash. Substituting this value, we will be getting that this mod of L minus L dash is lesser or equal to 2 by third of mod of L minus L dash. Now just imagine, have you ever seen this situation that a part is less than the whole? No. Here, this is a whole quantity and 2 by third is the part of L minus L dash. So this relation is not true. So from here, we conclude to, from here, what we get a contradiction. This relation is never possible. That's why a convergent sequence cannot have more than one limit. Hence, we come to a conclusion that the sequence cannot converge to two limit points. Combining the previous theorem that every convergent sequence is bounded and a sequence cannot converge to more than one limit, we conclude to one of a very beautiful theorem that every convergent sequence is bounded and has a unique limit. Now there is a tip for all the students that until unless you have not understood the theorem completely, do not copy down the notes in your notebook. Ask your doubts till you have understood each and every notion of the given topic. Until and unless, do not kill your curiosity. Do not fear of asking questions. ज़्यादा से ज़्यादा क्या होगा, टीचर आपको डांटेंगे, बट ट्रस्ट मी, इफ़ यू डू नॉट आस्क वो डाउट रह जाएगा, आप समझ नहीं पाओगे. आप कॉलेज में हो या स्कूल में हो, आप कहीं पर भी स्टूडेंट हो, वन मंत्रा इज दैट जब तक आपको समझ में नहीं आता है आप कॉपी में मत लिखिए. समझ लीजिए चीज़ों को, सुन लीजिए चीज़ों को, घर पे आइए या जब वो क्लास ओवर हो जाता है, take your time, whatever the things that your brain has accumulated, pin down in your copy them. And trust me, if you take this piece of advice, you will never feel that study is kind of a burden. You will feel that you are enjoying it. You are understanding the things in a very crystal clear manner. I hope I have made you this theorem very clear. We will meet in our next video. Thank you so much, and please do not forget to like, share and subscribe, as well as please follow me on Instagram. The Instagram handle is given in the description below. Thank you so much.